Hello, this is Brett, the STEAM tutor, and in this video we're going to be learning Hamming single code correcting through an example. In this example, we are asked to encode a binary value containing 8 bits. We are provided with a parity bit coverage chart and ordered pair 12-8. The value 12 tells us that we are going to have 12 bits in our final encoding, and the 8 tells us that we are going to have 8 data bits in the encoding. The first step you're going to want to do is lay out 12 spaces for your encoding. Next, we want to mark all the positions where your parity bits are going to lie. You can see where those are from the chart, however, it's just the bit positions that are powers of 2. Now that we have marked all of the parity bit positions, we will fill in the rest of the spaces with our data values from left to right, skipping over those parity positions. Now we want to fill in the parity values. What we want to do is put a 1 if there is an odd number of 1s in its coverage, and a 0 if there is an even number of 1s in its coverage. What we're going to do is make sure all of those coverages have an even number of 1s. You can see the coverage in the chart provided. If you don't have a chart on an exam or something, P1 is going to have coverage of all the bit positions where the first bit in its binary representation is a 1. So for instance, with the value 3, its binary representation is 1, 1. Since its first bit is a 1, it's covered by the first parity bit. The next parity 2 covers the second from the right. So for instance, there's a 1 in the second from the right position, so it would also be covered by parity bit 2. But using the chart, the first parity bit is going to cover all the odds. So let's look at how many 1s we have. So first I'm going to mark all of those positions. And as we can see, we have 1, 2, 3 1s. So we are going to want to place a 1 in the first parity bit position. Next, let's encode parity position 2. I'm going to first mark all of the positions that it covers. So as you can see, we have 1, 2, 3, 4 1s. So we want to place a 0 in parity bit position 2 in order to preserve the even number of 1s. Next, let's encode the value for parity position 4. This one is going to have representation over 4 to 7. And then 12. As we can see, we only have one 1 in this coverage, so we are going to add a 1 in parity position 4. Alright, lastly we're going to look at parity position 8. This is going to be all of the bits behind it, including itself. We have 2 1s, so we want to preserve the even number of 1s, so we'll place a 0. Okay, and this is our encoded value. Next, let's check for errors and decode. So for the purpose of this example, let's assume that through transmission, one of the bits got flipped from a 1 to a 0. So before we need to decode, we don't know if there's an error or not. So what we have to do is we have to do our error checking. What we'll do is we'll just simply look at our parity bits coverages and we'll determine if there's an even or odd. If there's an odd, then we know that there was an error, and we'll work our way through all of the parity bit positions. So let's first start with parity position 1. So we're going to look at all of the odds again. Okay. We have three ones in this parity coverage. So we detect an error. Next, let's go to parity position 2. Now, parity position 2 is going to be groups of 2. So let's see, we have 1, 2, 3 ones. So once again, we have detected an error. Let's go to position 4. This is going to be 4, 5, 6, 7, and then 12. So if we look, we have an even number of ones. So we have 2, therefore we detect no error. Now let's go to position 8. That is going to be all of the bits following it. We have 1, 1. So we have an error. Now in order to correct our error, we will sum all of our values of our parities. So for instance, we have P1, P2, and P8. What you do is you just take their respective value. That's going to be 11. That tells us that we have an error in the 11th value. And if you remember, that is the bit that we flipped. So it successfully found the error. So before we decode, we want to flip the value back. Okay, so now in order to decode, what you're simply doing is removing all of your parity bits now that you know that you have the correct value. So we don't need to look at this value anymore. We don't need this position, or this position. So our final encoded value, or sorry, decoded value is 1, 0, 0, 1, 0, 1, 1, 0. And that is the value that we started with at the very beginning. Alright, I hope this has been helpful. If it has, please give the video a thumbs up and subscribe.